Less than speak greater than process management and scheduling algorithms less than, speak greater than. Less than speak greater than a simple explanation of process management and scheduling algorithms. Less than, speak greater than.
AI adventures. Exploring the wacky world of AI search algorithms. 1. AI search. It's not rocket science, but it's close.
Right, Dr. Bob. Let's dive into this AI search stuff. Sounds a bit intense, doesn't it? Like something from a sci-fi movie.
Not really, Amelia. Think of it like this. You're looking for a specific chocolate bar in a massive supermarket. A normal search is like walking up and down every single aisle. Exhausting.
AI adventures. Exploring the wacky world of AI search algorithms. 1. AI search, beyond Google.
Right, Dr. Carter. So AI search algorithms sounds thrilling, doesn't it? But, what's the big deal? Why should we care?
Operating systems, from punch cards to pixels. A fun and insightful look at the evolution of operating systems, explained simply for tech enthusiasts.
Coding Theory Decoded. A casual exploration of automata theory concepts for engineering students. DFAs and NFAs. Demystified.
Hi Dr. Sharma, thanks for joining me today. Let's dive into DFAs and NFAs. For our listeners who might be a bit hazy on these, can you give us a simple explanation?
Absolutely, Rohan. Think of DFAs, or deterministic finite automata, as super simple robots. They follow a strict set of rules, one step at a time. They read an input string, and based on that input and their current state, they move to a new state. If they reach an accepting state at the end, they say, yes, this string matches, otherwise, no.
Okay, so it's like a flowchart, step by step?
Exactly, very much like a flowchart, but with specific states and transitions based on input symbols.
And what about NFAs? What's the difference?
NFAs, or non-deterministic finite automata, are a bit more flexible. They can be in multiple states at once. For a given input, they can move to multiple possible next states. It sounds weird, but it's powerful.
Multiple states at once? That sounds complicated.
It sounds complicated, but the concept is simple. Imagine you're at a crossroads and you can go multiple ways simultaneously. That's essentially an NFA doing its thing.
So, an NFA is less rigid than a DFA?
Precisely. A DFA has only one possible path for each input, while an NFA can explore multiple paths concurrently.
So, is one better than the other?
That's a great question. Both are equally powerful in terms of what languages they can recognize. Any language a DFA can recognize, an NFA can also recognize, and vice versa. However, NFAs can be easier to design for some problems.
Easier to design? How so?
Sometimes, expressing a complex pattern in an NFA's diagram is more intuitive and concise than forcing it into a DFA's rigid structure. It's like choosing the right tool for the job.
Got it. Can you give a simple example of a DFA or NFA in action?
Sure, let's say we want to design an automaton that accepts strings containing only A's. A DFA would simply have two states, one initial and accepting state for A, and a non-accepting state for any other symbol. Simple and deterministic.
In the NFA version?
An NFA could also do this. It would be essentially the same, although you would usually represent it like the DFA for simplicity. The power of the NFA only really shines when you have choices or ambiguity in the input string.
What are some real-world applications of DFAs and NFAs?
These are fundamental in lexical analysis in compilers, text processing, network protocols. Anywhere you need to check if an input string conforms to a specific pattern.
Lexical analysis? Could you elaborate?
In compilers, the first step, lexical analysis, involves breaking down source code into tokens, keywords, identifiers, etc. DFAs and NFAs are crucial for recognizing these tokens efficiently.
So they're like the gatekeepers of code, ensuring everything's in the right format?
Exactly. They are the first line of defense, ensuring only valid code proceeds to the next stage.
That's really interesting. What about the limitations? Are there any problems they can't solve?
DFAs and NFAs are limited to regular languages. They can't handle problems requiring unbounded memory or complex recursive patterns.
Unbounded memory? What does that mean?
It means they can only remember a finite amount of information about the input they have processed thus far. They can't store and later retrieve an arbitrarily large amount of data.
So, for more complex tasks, we'd need something more powerful?
Yes, for those we would use things like context-free grammars, push-down automata, or Turing machines.
Okay, that makes sense. So, to summarize, DFAs are deterministic and simple, while NFAs allow for multiple possibilities. Both are powerful tools for pattern recognition, but are limited to regular languages.
Perfect summary, Rohan. They form the bedrock of many aspects of computer science, and understanding them is key for anyone in the field.
Thanks so much, Dr. Sharma. This has been incredibly helpful. I'm sure our listeners appreciate the clear explanation.
My pleasure, Rohan. Happy to help.